Before we get started, I want to let you know that there's some new limited edition merch for sale at the merch store.
North America was recently graced with a total solar eclipse. Those of us lucky, or obsessed enough to be on the narrow path of totality, and also lucky enough to not be under a giant blanket of clouds, witnessed the most wondrous of all celestial phenomena. The sun went dark, the solar corona blazed, and even the ruby red top of the solar atmosphere became visible to the naked eye. Jupiter, Saturn, Venus, and even a comet straddled the new black hole sun. Part of the reason the total solar eclipse is special is that it's so rare. If it happened every day, you probably wouldn't even look up. Well, good news for those of us who missed the eclipse, whether due to weather or geography, there is such a phenomenon. It's that enormous ball of rock that's just hanging there in our sky. The one that happens to be the exact size to blot out the sun now and then, and without which we may have never figured out how the universe works or begun our exploration of it. It's the moon, and it's our stepping stone to the universe. Today, we learn how to take that step. Seriously, our moon is crazy. You know those over-the-top science fiction skyscapes, multiple suns, multiple moons, gigantic moons, or Saturn-like planets, or crazy nebula that fill half the sky? The reason we have to come up with that stuff is because our own sky is already pretty sci-fi over the top. No other planet in our solar system has anything like the moon. The only physically larger natural satellites are 3 of Jupiter's and 1 of Saturn's moons, and our moon is still comparable to those in raw size. But the gas giant moons are tiny compared to their host planets. Our moon is by a long, long way the largest relative to the planet it orbits, making the Earth and the moon practically a binary planet system. It's generally accepted that our moon formed when a Mars-ish sized planet that we call Theia slammed into the still-forming Earth, throwing up one of those sci-fi planetary rings that quickly pulled itself together into the moon. And we've talked about this hypothesis before. That seems like a rare enough event that some argue that such outsized moons are probably rare in the cosmos. If so, then an alien looking up at our sky would be like, what the hell is that thing? And then they might think that it's no wonder that these otherwise primitive humans were so quick to figure out so much about the universe from the Big Bang to the end of time. I mean, we could only pretend that we are at the center of a small universe for so long when we can literally see the detailed surface of another world with the naked eye. The moon is both our metaphorical and literal stepping stone to the universe. And I'll come back to the literal part in a minute, but just let me drive home that metaphorical part a bit harder. The moon gives us a few telling clues about our place in the universe. First, it's round. The moon is pretty clearly a giant ball of rock with a cratered surface. It's a world, surely an essential clue that the other bodies of the solar system, including the Earth, are of similar form. 2. Its eclipses and lunar phases. Now, we saw this in the last episode. These phenomena told us the basic structure of the Earth-Moon-Sun system, but also allowed us to figure out the distances to the Sun and the Moon, our first hard calibration of the immensity of space. And watching the Earth's round shadow cross the Moon really drills the whole Earth isn't flat thing. And 3. The Moon's gravitational attraction to Earth. It's said that Isaac Newton figured out his law of universal gravitation after watching an apple fall. But the other part of the story is that to figure out the relationship between gravitational force and distance, he needed a much more distant object that is also subject to Earth's gravity. He used the Moon. Without the Moon, it may have taken much longer to figure out gravity. And without that, don't even think about starting up a space program. So the Moon has been one of the most important theoretical stepping stones to our understanding of the universe. And we've long understood that it could also be our literal stepping stone. It is humanity's first destination beyond the atmosphere. Through the Apollo programs, humans walked on another world. The last time that happened, though, was over half a century ago. It's no longer something we do, it's something we did, like back in history. It's been argued that we no longer need to put people on the moon. We got all the rocks, that particular Cold War ended, and perhaps most importantly, we convinced ourselves that interworld travel is possible. Our eyes became fixed on Mars as the next human destination. But can you imagine us even contemplating a trip to Mars without first having landed on the Moon? So, thanks Moon, job well done. Please continue your regular activities of sloshing our oceans around and making the night a bit more romantic and moonlit. Except, are we really done with the Moon? In recent years, our collective intentions have swiveled back to the Great Sky Rock. Just last month, the very first private company achieved a soft landing on the Moon. Intuitive Machines managed to touch down its Odysseus lander about 300 kilometers from the lunar South Pole and took spectacular images of the surface and gathered important data for future missions. The soft landing could have been a bit softer because Odysseus tipped over on touchdown, which did shorten its life expectancy but didn't dent its overall success. This was such a major achievement because the lunar poles are more heavily cratered than the equator and experience extreme temperature fluctuations that landers have to be resilient against. Intuitive Machines didn't just achieve the first private soft dish landing, this was the first soft landing by the United States in the 52 years since Apollo 17. But our return to the Moon has been building up momentum for some years now. In August last year, India became only the fourth nation to soft land on the Moon, after Russia, then the US, then China. Its Vikram lander, part of the Chandrayaan mission, was also the first craft to land in the lunar South Pole region, where it successfully deployed its Pragyan rover to explore the area. But why this current obsession with the lunar South Pole, if the poles are so hazardous? Well, because of a game-changing fact that India's first mission, Chandrayaan-1, helped establish. It found water at the South Pole. Back in 2008, Chandrayaan-1 dropped its moon impact probe into the Shackleton crater. The hard landing craft detected significant water in the tenuous South Pole atmosphere on its descent, confirming earlier evidence from a number of other missions. To be clear, these detections are not quite direct and require interpretation. There's strong evidence for hydrogen in the tenuous lunar atmosphere, likely from actual ice or water or hydroxyl-bearing minerals in the soil, and direct detection of those minerals has also happened. We've also known for a while that there was real water ice in the permanent shadows of some lunar craters. But there's an emerging consensus that there must be significant ice even in the sunlit lunar soil. That means there's just way more water than we thought. It's not even clear how it got there. Perhaps it was brought in by comets like Earth's oceans might have been. Or perhaps protons in the solar wind slam into oxygen in lunar minerals to produce H2O. There's some evidence that the lunar surface water is being continuously replenished, so the latter may well be important. Whatever the source, the presence of water turns the Moon from a pretty but dead skyrock into our stepping stone to the stars. If you've spent any time in Arrakis, you know why water is such a game changer. Although it's abundant on Earth and Caladan, it's heavy and so expensive to pull out of a gravity well. It costs a couple of $1,000 US to get every litre of water to the International Space Station, let alone to the Moon. Even with Fremen stimsuit level water recycling, good luck building a decent sized base without water, let alone even a small biosphere. But an enormous lunar source of water makes all of this possible. Which brings us back to human plans for the Moon, and to China. China has been vigorously pursuing lunar exploration for longer than India with its uncrewed Chang'e program. Chang'e 3's successful 2013 landing made China the third nation to achieve soft landing, after the US and Russia efforts both ended in the 70s. Chang'e 4 was the first anything to land on the far side of the Moon in 2019, and Chang'e 5 is the first non-crewed lander to successfully return lunar material to Earth. That was in 2020. The next Chang'e, number 6, is supposed to launch next month and to return samples from the apparently watery South Pole. Number 7 will also mess around at the South Pole, but number 8, Chang'e 8 will do a 3D printing experiment using lunar regolith and will carry a sealed ecosystem experiment, all in preparation for the next phase, a crewed lunar base. China aims to land humans on the moon by 2030 and by 2035-ish to establish a permanent base in collaboration with Russia, but ostensibly as an international facility. The United States may have been the first and is still the only nation to have put a human on the moon, but it's been distracted by another shiny thing in the sky. NASA's space exploration has been really focused on Mars, with excellent reasons. Besides being the next obvious human destination after the moon, we've known for much longer that Mars has water, both to support a base but also perhaps to once have supported life. The impact of finding evidence for that would be much, much bigger than even the first moon landing, in my opinion. The moon could never have evolved life, but with water, it could support our life in the future. And so again, the United States is finally turning its eyes back to the moon. The Artemis program aims to send crewed missions to the moon, first in orbit and then to the surface. It consists of the Space Launch System, a super heavy lift rocket carrying the Orion spacecraft. Other vehicles will also serve the larger Artemis mission, like the SpaceX Falcon Heavy carrying the Dragon spacecraft. In 2022, the uncrewed Artemis 1 mission put an Orion spacecraft into lunar orbit before successfully returning it to Earth. In 2025, Artemis 2 will do the same, but with people, 4 astronauts. And then in 2026, Artemis 3 aims to put the first American boots on lunar soil since Apollo 17. The other big goal of the Artemis program is the construction of the Lunar Gateway space station, a crewed station that will be constructed in lunar orbit over the rest of this decade. This one is with participation from the Canadian, Japanese, European and Dubai space agencies. There's been some criticism of Gateway, basically amounting to the question of why build a station in orbit when you could build a station on the moon. Fair point, but ultimately the US is planning to build that surface base, and the Gateway station is supposed to support that goal, as well as be a general staging station for a variety of solar system missions. Speaking of, there's something else that lunar water is good for. Apply an electric current to H2O and the molecule splits, giving you hydrogen and oxygen. This is electrolysis. These gases readily recombine into H2O, releasing the same energy it took to separate them, but now explosively, like in a rocket. Water can be used to make rocket fuel. The idea would be to place some giant solar arrays on the surface of the moon near the poles and use the energy to slowly harvest hydrogen and oxygen, turning the moon into a refueling depot. The weight of fuel is one of the biggest limiting factors in determining spacecraft weight and range, and dragging that fuel out of Earth's prodigious gravitational well is the hardest part. With a lunar fuel depot, the most fuel any mission needs to carry is the amount needed to reach the moon. From there it can be refueled for its onward journey to Mars, the asteroid belt mines, its return to Earth, or perhaps some destination beyond the solar system. And sure, I guess being able to dock at the Lunar Gateway is better than having to land on the moon before moving on. If all goes according to the various plans, or even just some of them, in as little as 10 years, we'll have our first deep space station, our first crewed lunar base, maybe even a couple of surface bases, and we'll be working towards the ability to refuel spacecraft from lunar orbit. There are plenty of other plans also, like the giant radio telescope on the far side of the moon that we talked about previously. For the most part, our return to the moon seems like an inevitable and positive thing, with lots of international collaboration to build a shared and peace-forward infrastructure. For example, the US just announced a move to create an internationally agreed lunar standard time to account for the fact that time ticks a tiny bit slower on the moon compared to Earth's surface on account of general relativity. But there are signs of competition already arising, and the whiff of a new space race is in the air. China versus the US seems to be the main superpower standoff, with each asserting their leadership. Russia is aligning more with China, Europe with the US, and various nations are sidling in one direction or the other. And then there's the private sector, which will play an increasingly large, if not dominant part of the game going forward. Whatever the outcome, it's coming, and pretty fast. Odds are that within the decade, perhaps much quicker, someone will be back on the moon or close to it, and probably that someone will be human, which is a win for all of us. We've been snoozing a bit on the moon, but soon we'll be walking on it again. And hopefully soon after, that weirdly giant skyrock will fulfill its potential as a fortuitous stepping stone towards our future exploration of the rest of space-time.
Hey everyone, before we go, I wanted to let you know that we have 2 new limited edition merch items up at the merch store. First up is our first ever black hole enamel pin. This is a 1.5 inch enamel pin on hollow foil backing card designed by the Spacetime GFX team. These pins are limited edition pre-sale and you will need to put in your order by April 29th, with the pins shipping during the second week of June. Once we're out of stock from the pre-sale, that's it. Next up is our Star Wars inspired Spacetime t-shirt and sweatshirt, designed by our very Star Wars nerdy director. This limited edition design will be available until May the 4th, be with you. And if you'd like your shirt to arrive before Star Wars Day, you'll need to put in your order by April 25th. To put that order in, just head over to pbsspacetime.com/shop or click the link in the description.